Hi there, this is Charlotte, doctoral student here at the iSchool at Syracuse University. Today I'm sharing some resources for week 4 of our Introduction to Data Science with R. This week we cover Chapter 7 of the course ebook on sampling and inference and Chapter 8 on big data. Skew, or lopsidedness of a distribution, is one concept that comes up in Chapter 7. Wikiversity has a nice brief definition of skew. They explain that the direction of the skew of a distribution is the side with the longer tail, and that in a skewed distribution, the mean is typically farther out in the long tail than the median. So, for example, the distribution of student scores for a very difficult quiz where there are a lot of low scores might be skewed to the right, with most student scores piling up on the left side of the distribution, leaving a long tail on the right. Right skewed distributions are also described as having a positive skew. Another concept in Chapter 7 is the law of large numbers. The main takeaway is that if you run a statistical process a large number of times, it will converge on a stable result. The Khan Academy video on the law of large numbers goes into this in more detail. Skip to the 7-minute 25-second mark for a discussion of the gambler's fallacy, a mistake people sometimes make in applying the law of large numbers. The central limit theorem is another important concept in Chapter 7. It says that when we are looking at a distribution of sample means, the mean of all those sample means gets really close to the actual population mean. And when we have a large number of samples, something called standard error goes down. Standard error is just the standard deviation of the distribution of sample means. To learn more about standard error, check out Paul Anderson's explanation on YouTube. Chapter 8 of the ebook is about big data. Big data is an important topic in many areas. If you're interested in big data in science, a key person to know about is Jim Gray. Jim Gray was a Microsoft researcher who saw possibilities for big data to fundamentally change science. His ideas are explained in a free ebook called The Fourth Paradigm: Data-Intensive Scientific Discovery. On the same page where you can download the Fourth Paradigm ebook, you can also read a review from the New York Times that gives a nice synopsis of the book. And you can also read a book review by James Collins titled Sailing on an Ocean of Zeros and Ones that offers a critical perspective. Unfortunately, Jim Gray died unexpectedly in 2007 when he was lost at sea in a sailing accident. But his work has had a significant impact. For example, today many scientists use relational databases to manage their data because of Jim Gray's influence. And knowing how to work with databases and how to support researchers with managing their data is now a growth area for academic librarians. The Fourth Paradigm book is from 2009 and is focused primarily on science that is inherently big data oriented, which is actually only a small percentage of all of science. Today there's more conversation about small science and small data, which people sometimes refer to as the long tail of empirical research. An emerging area in the research infrastructure community is providing better research data management support for researchers who work with small data sets. This might not change science in the big, exciting way Jim Gray describes in the Fourth Paradigm book, but it could have the effect of reliabilizing data and indirectly supporting big science by making it possible for researchers who are working on a smaller scale to be able to share their data. Big data is also a hot topic in healthcare. An article from this past summer's Government Health IT explains the 5 big data hurdles in healthcare. Skip to point number 5 to read about how big data might fundamentally change healthcare. Big data is also a big issue in public sector development. At the link I share from UN Global Plus, you can either download a 47-page white paper or scroll to the bottom of the page at UN Global Plus and watch a 14-slide presentation in SlideShare that covers the big data issues in this space. An example is using social media to inform disaster response to gain richer and timelier insights on the experiences of vulnerable communities so that we can implement better informed and more agile interventions. Social media is an interesting area for working with big data. Here at the iSchool at SU, we have faculty with expertise in natural language processing and in doing social research using algorithms to work with social media data, which are helpful for those who hope to work with social media big data. I hope you find these resources useful. Good luck with week 4.